All right.
All right, so I've had a lot of questions about predicting products. So I'm just going to go over, um, kind of what's given. So in our 5 types of reactions, these things are going to be our given reactants. So on the left side of our arrow, it's going to be one of 5 combinations. We're going to have 2 compounds. That'd be double replacement, a metal element in a compound, metal and nonmetal, which are both elements, 1 reactant, or a carbon compound that has mostly C's and H's. There could be O's in that as well, and oxygen. So those are like the 5 possible combinations for identifying reactants or reactions based off reactants. So if I look down here, the question that I'm asking is, what is that? What is the reactant that I'm given? Which of these does it match up with? And if I understand kind of some of those basic elements of chemistry, this should tell me that it is a decomposition 1 reactant, right? And the question I would ask is, and you can type your response in the chat here, what is this one? What is CaCl2 and FeNO3 2? What are those? Which of these is it?
Hold on. The double replacement.
Double replacement, right? Yeah, because I have 2 compounds, right? Compounds, double replacement. Yeah, and then this one, I have C2H6O2 and oxygen, O2, which tells me that it's
combustion.
Combustion, yep. Okay, next one. The question is, what is lithium? It's a metal. And then what's that?
Are you asking me?
Yeah.
Oh. A compound?
Yep, so it's a metal and a compound, so that's single replacement.
Okay.
And then lastly, I have Sr, which is a metal, and N, which is a non-metal. So I have 2 elements, which are then giving me a synthesis reaction.
Yeah.
So if I can identify based off of the reactants, then I can go back and be like, all right, this is, at least for our class, what we're going to do for writing products. And that's these. And so single and double replacement are really similar. They're actually the same rule for writing products. The difference is that one of the metals is going to be an element and one's going to be a compound, and in a double replacement, both of them are going to be in compounds. So in synthesis, you got to crisscross into 1 product. You're making 1 product or synthesizing 1 product, decomposing, you're breaking it apart into the elements. That's our rule for this class. It isn't always like that. And combustion is always CO2 and H2O. Okay, so if decomposition is my first one, I just go here, okay, I identified as decomp from 1 reactant, and then I'm just going to split it into the elements. Okay. So I just go on this side, I got K. Plus, I'm just going to copy that really quick. C plus O. And then I have to decide, are any of these a sneaky 7? K is not, C is not, and O is. So O, when it's by itself, gets a 2. Okay, so that just kind of takes us down. The 7 elements that are sneaky 7s are H, N, O, F, Cl, I, and Br. I think that's 7. 1, 2, 3, 4, 5, 6, 7. And when do they get a little subscript 2? I'm just going to add the 2's in really quick. When they aren't in a compound. Okay, so that's the time that they get a 2. So like right here, nitrogen is, I'm just going to see if I can do, there we go. Nitrogen's by itself, so it gets 1 there. Okay, so decomposition is split into the elements I'd have to balance. I'm not going to worry about that right now. Okay, so then I go, let's do double replacement and single replacement last. Let's do combustion next. What are my 2 products for combustion?
Uh, wait, what? Your two products?
Yeah,
H2O and O2, or
it's
CO2 and H2O or something
yeah,
like
it's
that.
always CO2 and H2O. So if
Yeah.
I can identify it as combustion, I just go, all right, this one's going to be CO2, and this one's going to be H2 and O. Okay. So combustion is actually probably the simplest one if you can identify it.
Mhm.
Uh, and all the other ones require, so decomposition and combustion are probably the simplest. The other ones require crisscrossing and charges. Okay, so let's start with synthesis because it's probably the simplest one. Synthesis, what do I have to do? I have to crisscross into one product. Okay. So that means I have to make it into one compound on this side. So I need SR and N. That actually is going to stay there. But what I want to do is let's take a look at the periodic table. So what I have to do is look at, all right, what's the charge of SR and what's the charge of N? So I just go to my ions periodic table and I have SR here, which is a +2, and N, which is a -3. Okay, so I have to find the charges. And I'm going to reference this a lot, just understand that maybe that's where I'm looking. Let me know if you have questions about where I'm getting it from. Oh, where am I at here? I think this is it. Yep, there we go. Okay, so SR was a +2. And N was a -3. And then when I crisscross, the charge from strontium ends up going to the bottom of N, 2 down there. And the charge from nitrogen ends up going down there to the strontium. And then we're done. Is that part okay?
Yeah.
Okay. So then I go to single and double replacement. And in double replacement, I have to crisscross twice. And in single replacement, I have to crisscross just once. Okay. So this is single replacement identified based on an element in a compound. So what is Li going to switch spots with? What part of it?
The CO3.
Well, it's going to go with.
Or no. Sorry,
Yeah.
The K.
Right.
Too.
It switches spot with the other metal.
Yeah.
And then I would have to crisscross again. CO3 is a polyatomic ion. And I know that because if it wasn't a polyatomic ion, it would look like this, CO3. That's what it would look like if the 3 was from the lithium. But since I don't have those parentheses, it tells me that that's part of it. So the charge of lithium is 1. So I have 1 CO3. The charge of CO3 is 2. So I get 2 lithiums. Is that part okay?
Yeah.
All right. Now I go to this one. And I have double replacement. But again, the metals are switching spots. So what 2 things are switching spots?
Calcium.
Yep.
And iron.
Yep. So the Fe is coming over here where the Cl was, or Ca was, and the Ca is going where the Fe was. Now I have to re-crisscross things. Now, fortunately, on this one, I did things pretty easy. From my periodic table, what's the charge of calcium?
+2.
Yep. And then in the polyatomic ions, what's the charge of nitrate?
-1.
-1. Okay. So if I had a 2 up here, it'd come down here, is where I see it. And then if I had a 1 there, it'd come down. So that's actually correct.
Okay.
And then if I look at chlorine, what's the charge of chlorine?
-1.
-1, right? Oh, what the heck? And then what charges are listed for iron?
I think it's +2, +3, yeah.
Yeah, it can be a +2 or a +3. So I have to choose which one is used, but I have to come to this side to look. So if I look at iron nitrate, where would I see the charge of iron?
Right by the iron. Or I mean, on the other side.
Yeah, after I crisscross, it comes down here. So which charge of iron did I end up using?
+2.
+2. Okay, so I'm crisscrossing iron +2 with Cl, which is a -1. And I get Fe1 Cl2. So it's going to end up looking like that. Okay, so that's how I write those products. So the big key is off of reactants, can I identify the type of reaction that I have? Right. That's the idea right here. So I'll copy and paste that answer in later. I'll just do it right now. But the reason why they get a 2 when they're alone, but it's all based off of getting a full shell of electrons. So those elements, when they're alone, they bond to another atom to get a full shell of electron. What? That's so weird. Still weird. Whatever. Yeah. So what I want to do is, do you just want to take a picture of this box really quick on your computer?
Yeah.
And let's
Okay,
go
so
down and work on identifying first. That's all we're
Okay.
going to work on, is identifying. Got it?
Yeah. Sorry.
All right, you're good. So let's come down here. Number 6. We're looking at the reactants now, and we have to identify based off of that alone. So
Okay.
what type of reaction is it? And maybe we can just break it down. What is K, element or compound?
Element.
Element. Okay, is it a metal or non-metal?
Metal.
Metal, yeah, left side of the staircase. Chlorine, element or compound? This is a tricky one.
That's a sneaky 7.
Yeah, so it's just an element is actually what it is. But it's because it's by itself, it gets a 2. Notice K is not a sneaky 7, so by itself it doesn't get a 2.
So then would that be synthesis?
Yep, so that's synthesis. Okay, that's synthesis. Before we go on, let's identify the other synthesis reaction that's on here. What is the other?
Isn't it? No, that's not right.
It's on the screen right now.
Is it 7? No. Nope. Ignore that. 11.
What do I need? I need to have 2 items.
Oh yeah, sorry. Okay. I don't know.
14, yeah.
14? Yeah. Okay.
Because I got a metal barium and a non-metal phosphorus. So the reaction type is going to be synthesis. Okay. So in a synthesis reaction, what's my rule for writing products?
Crisscross.
Crisscross. Okay, so I need to find the charges. So if you have your periodic table, what's the charge of potassium?
+1.
And what's the charge of chlorine?
-1.
So when I crisscross 2 1s, which of these will I get?
C.
Letter C. Yeah, and then that's going to be your answer. Okay. Let's go down to number 14. What's the charge of barium?
+2.
What's the charge of phosphorus?
-3.
Okay, and then which of these will I get when I crisscross a 2 and a 3?
B.
B. Yep. And then there's my answer. And this is actually what like your quiz will look like, is that.
Okay.
Yeah. All right. So let's go to number 7 here. What type of reaction does that look like?
Combustion.
Yep. Right. I have a carbon compound, C's and H's, and an O in this case, and oxygen, O2. And what's the products for a combustion reaction?
Nope. Yeah. CO2 and H2O.
Yeah. Always CO2 and H2O. Okay. So what's my other combustion reaction on here?
Whoa. What happened? Okay. 12.
Yeah. Number 12. Right. I got another carbon compound and an oxygen. What's happening here? Combustion. And then what are my products for combustion?
CO2 and H2O.
CO2 and H2O. Yeah. So that one, hopefully, the sooner we can recognize that, the easier it gets. All right. Let's go to number 8. Okay. We have BE. What is BE?
A metal.
It's a metal. And then what is this?
That's a compound.
It's a compound. So I have a metal and a compound, which tells me that it's going to be a
single replacement
reaction. So then when I write the products for this, my metals are going to switch spots. So that's going to be the first part of it. Okay, so this is single replacement. What's my other single replacement reaction that's on here where I have an element in a compound, a metal in a compound more specifically?
13. No, that's double replacement. 10? Question mark, question mark.
What is that?
That's, wait, is Li? Yeah, 10, right?
It's a compound, but notice I need plus
Oh, yeah,
metal.
there's two. Sorry.
You're okay.
Okay. Oh, 9.
Yeah, it's just the next one.
I didn't see 9. Okay, I didn't see it. We just don't talk about it.
That's cool. It's fine. All right. So now when I write these, what am I going to do with my metals? They switch spots. Okay. So which thing is going to be by itself like BE is in my products?
Li.
And number 8?
Oh, I thought we were doing 9. Okay.
Right.
Okay, sorry. Fe.
Fe. Okay. Which of these is the only one where Fe is by itself?
A.
So boom, right there. I didn't even have to worry about crisscrossing in the multiple choice because I did it based off that. Okay, now number 9, what thing is going to be by itself?
Li.
Li. Okay, so I can immediately throw out A because that would be an answer to a decomposition problem. Okay, now the question, what's the difference between these two problems, B and C?
The 2 on the Li.
Right, so the question is, does Li get a 2 when it's by itself? No, it's not one of my sneaky 7. So what's my final answer? B. Because Li does not get a 2. Doesn't break apart into elements because it's a single replacement. And then does Li get a 2? No, because it's not a sneaky 7. Okay. So let's look at number 10. What type of reaction is number 10?
Okay.
Where I have, we already said before, one reactant.
Yeah, you want to go back up to that? Okay, one reactant. Decomposition.
Decomposition. So what I'm going to do, I'm going to split it into the elements and watch out for sneaky 7s. So which answer can I throw out right away?
C.
Right, yeah, because it doesn't split into the elements.
So then would it be A?
Yeah, so the difference between A and B is N and O have 2s, and those are sneaky 7s, so those are the correct answer. Okay, so let's come over here. Out of the remaining 11, 13, and 15, which one is my decomposition reaction?
11.
Yeah, 11. Okay. So which one, or what am I looking at here is basically, do I keep the 3, or do they both get 2s, or does only one of them get a 2? So that's really what this one's asking me about. All of them are showing you a correct split of the elements, but now I have to decide subscripts. So every element should be bare, no 2, unless it's a sneaky 7. So the question is, are any of these sneaky 7s?
Cl2, chloride, right? Chloride.
Right. So I can throw out this one because Fe is not. I'm going to throw out this one because it should never get a 3 when it's by itself. So my answer is C.
Yeah.
Okay. Now 13 and 15, the last type that we haven't talked about is double replacement. 2 compounds, the metals are switching spots. Okay, so double replacement and double replacement. So these are a little bit more complicated.
Yes.
Okay. But hopefully I should be able to throw out at least one of my answers right away. Okay, so when I look at this, what's the metal in this compound?
Iron.
Iron, Fe, yep. And what is it in this one?
Aluminum.
Aluminum. Okay, so which 2 elements are switching spots? Fe and aluminum. Which one does not show them switching spots?
A.
Letter A, it shows them going together, which is totally different. Okay, so now iron can be multiple charges, right?
Yep.
So I don't necessarily want to start with that one, but aluminum and chlorine, if I look at my periodic table, those both only have 1 charge. So I'm going to figure out what that would be when I crisscross. So aluminum's a +3, chlorine's a -1. So if I were to crisscross those elements, what will be the answer that I end up getting for my product? Al's a 3, Cl's a 1. Is it going to be this one, AlCl2, or AlCl3?
AlCl3.
AlCl3. So that means by process of elimination, I can say that it can't be C, leaving me with B as my answer. I'd even have to figure out that iron was a 2. You could figure that out, but you don't have to. Okay, so let's go to 15. I got, what was my metal in this compound?
Calcium.
What's my metal in this one?
Nickel.
So which one can I throw out?
C.
C, because they're going together. They're not switching spots. Okay, so now I got to figure out the correct crisscross. What's the charge of calcium always?
Whoa, I don't know what happened. Hold on, my phone tweaked out. Okay. Calcium is +2.
+2. Okay. So now I have to figure out, is ClO3 a 2 and they cancel? Or is it a 1 and I end up with a 2 here? That's what it's asking me to figure out. So what's the charge of ClO3 from my polyatomic ions list?
-1. Right? No.
Yeah, it is right. You're right. -1.
Oh,
So
okay.
which of these, which crisscross is correct? A or B?
B.
B. Yeah, because calcium's a 2. Because calcium's a 2. Okay, so we got that. So that's really all we got going then. And this is what your problems are going to be like. So give me 2 seconds here.